Hello friends and my dear students, I welcome you all to my channel. So this is set 2 of 10 good problems on the chapter of factorization. I have already completed the first set of 10 good problems in the previous video. If you have not watched that, I highly suggest and recommend that you watch that video also. So this video is part of the playlist Maths 8 Hot, where HOT stands for High Order Thinking Problems, where I come up with uh, 10 good problems on each chapter as and when they are completed in the other playlist, that is CBSE Maths 8 RS Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the 10 good problems of set 2 on the chapter of factorization. Okay, so I have the 10 good problems set 2 on the left hand side, and on the right hand side I will solve the problems. I hope the problems are visible and you can see it properly. The PDF of these 10 good problems will be given, the link of the PDF of these 10 good problems will be given in the description below. You can also check that out, check the PDF from that link. As usual, please try to solve the problems yourself first. Ideally, you should be able to solve these 10 good problems in 40 minutes, that is roughly taking 3 or 4 minutes per question. If you are stuck at any problem, then only you refer this solution video. So let's get started in solving the 10 good problems. The first problem says the quotient when a polynomial is given is divided by m cube plus 1, product of m cube plus 1 and m plus 1 is. So one polynomial is given, it is of having of degree 5, that is m to the power 5 plus 2 m to the power 4 plus m cube plus m square plus twice m plus 1. It is asking if what will be the quotient if this polynomial is divided by the other polynomial which is expressed as a factor of two binomials, that is m cube plus 1 and m plus 1. What will be the quotient? So basically we have to find the division of the polynomial. The polynomial is m to the power 5 plus 2m to the power 4 plus m cube plus m square plus twice m plus 1. When we divide this polynomial with the other polynomial, that is m cube plus 1 and 1 plus 1, we have to find the quotient. So this kind of problems is better solved if you can factorize the numerator first, and then you will see if you can cancel out any factors from the denominator. That is, if m cube plus 1 or m plus 1 is a factor of the polynomial in the numerator, then we can easily by cancelling out the factors we can find the quotient. So let's first factorize this polynomial. So now you have to be very careful. You have to observe the terms very carefully, and see whether you can form any whole square. Now all the terms are connected by addition, so definitely we will not we are not getting any form like a square minus b square. So, but we are seeing if you notice the last three terms, we are having m square plus twice m plus 1. It is in the form of a square plus b square plus twice ab, where a is m and b is 1. So, and okay, so we have m to the power 5, 2m to the power 4 plus m cube plus m square plus twice m plus 1 plus 1. Now clearly we can see that all the terms are not having any common factor. If all the terms of the given polynomial are having a common factor, we always first factor out that common factor. Okay, Now you can see we can observe that m square plus twice m plus 1 it can be expressed, it is of the form a square plus b square plus twice ab, and it can be written as 1 plus m whole square. Now, okay, now what about these first three terms? From the first three terms, you can see we can take m cube as common, because the first three terms are having all are having m3 m to the power 3 as common factor. So if you factor out m cube from the first three terms, we get m square plus twice m plus 1, and we have already seen that the last three terms m square plus twice m plus 1 can be expressed as 1 plus m whole square. Now this expression inside the bracket is again, we can see it is of the form a square plus b square plus twice ab, where a is m and b is 1. So we can write m square plus twice m plus 1 as 1 plus m whole square, and we have 1 plus m whole square. So from these two terms, from these two expressions, we can, or rather groups, we can take 1 plus m, square of 1 plus m as common, and we get 1 plus m whole square and m cube plus 1. So this is the factorization of the given polynomial, that is m to the power 5 plus 2 to the power twice m to the power 4 plus m cube plus m square plus twice m plus 1. So we can now say that the division will be this divided by m cube plus 1 and m plus 1. Now clearly m cube plus 1 cancels out, and 1 plus m cancel out 1 plus m in the denominator. So the question becomes 1 plus m. 1 plus m is the question. So definitely the correct choice is B. So this kind of problem where you are asked to find the quotient of where you are asked to perform a division of two polynomials, it is often one good way of solving this kind of problem is to factorize the dividend, as well as the divisor. If the divisor is not given as a factor for this problem, the divisor is given as a product of factors, that is m cube plus 1 is a factor and m plus 1 is a factor. So if you factorize both the dividend and divisor, it will be easy to perform the division. Okay, let's do problem number 2. It says that the area of a rectangle is, let's say the area of the rectangle is, polynomial is given, the area is given as an algebraic expression which is a polynomial 6x square minus 30x minus 216, and the length is 3 into x plus 4. Length is given as another expression, that is 3 into x plus 4. Then it is asking what is the width. So definitely we know that for a rectangle, from mensuration we know for a rectangle area is equal to length multiplied by breadth. So this implies, if we consider A is the area of the rectangle, L is the length of the rectangle, and B is the breadth of the rectangle, then we have area is given as 6x square minus 30x minus 216 is equal to, length is given as 3 into x plus 4, and we have multiplied by breadth. So we have to not breadth, it is referred as width, so let's call it width. So W, so we have to find the width. So from this we can say that the width will be 6x square minus 30x minus 216 divided by 3 multiplied by x plus 4. So again we have to do a division of two polynomials, and the dividend is not factorized, whereas the divisor, that is the denominator, is in the factorized form. That is, it is the factor of it is a product of two factors. The first factor is 3 and the second factor is x plus 4. So the next task is to factorize the dividend. So let's once we have factorized the dividend, it will be easy to cancel out factors and find the width or perform the division. Now, this is a quadratic trinomial. We are trying to factorize this polynomial, that is 6x square minus 30x minus 216. So, this is a quadratic trinomial of the form px square plus qx plus r. And to factorize this kind of quadratic trinomial, we find two values a and b such that a plus b will be equal to q and a multiplied by b will be equal to pr. So for this polynomial, we can see that we see that a plus b is equal to minus 30 and a multiplied by b is equal to minus 216 multiplied by 6. Now, one thing, if you so this polynomial 6x square minus 30x minus 216, if you see that all the terms are having some common factor, then it is always wise idea to factor out that common factor. So I can clearly see that 6 the numerical coefficient 6 is a common factor in all the terms. So before performing the factorization, I would like to factor out 6 from all the terms. So this becomes 6 product of 6 and x square minus 5x and minus 36. So now we would like to factorize. So this was a little sorry. Now we are getting a different quadratic trinomial. We are having a different form of quadratic trinomial. So now we have to factorize this polynomial, which is of the form x square plus px plus q, and we know that we have to find, to factorize this polynomial, we have to find a and b, two numbers a and b, such that this colon stands for such that a plus b will be equal to minus 5 and a multiplied by b will be equal to minus 36. Okay. Now minus 36, we know the two factors can be 9 and 4. 9 and 4. So we know that the addition of a and b must be minus 5 and the product must be minus 36. So we can say we can create factors of minus 36 as minus 9 multiplied by 4. Minus 9 multiplied by 4, which is minus 36, and the addition and their sum, that is minus 9 plus 4 is minus 5. So you can consider minus 9 as a and 4 as b. So this the factorization of the polynomial quadratic trinomial x square minus 5x minus 36 will then become x minus 9 multiplied by x plus 4. So now we can say that width, this implies width is equal to 6 multiplied by x minus 9 multiplied by x plus 4 divided by 3 multiplied by x plus 4. So we can cancel out x plus 4 factor, and we cancel out 3 and 6, we have 2. So the width is twice of x minus 9, and hence the correct choice is D. D is the correct choice. So after solving a problem, I am pausing for a few seconds so that you can take a screenshot of the solution. Okay, let's do problem number 3. It says on dividing a polynomial is given by another polynomial we get. Okay, so this is basically a division problem. We have to find p multiplied by 4p square minus 16 divided by 4p multiplied by p minus 2. So this seems to be a relatively easier problem. So basically we have to find this division, and we can see that we have to factorize the numerator further. That is, we have to factorize 4p square minus 16. 4p square is square of 2p and 16 is square of 4 square. So we see the form a square minus b square, and hence we can further factorize it as p multiplied by 2p minus 4 multiplied by 2p plus 4 divided by 4p and p minus 2. Okay. Now in the numerator we can see that from these two factors we can factor out 2 as common factor. So we get 2 p minus 2 and also 2 p plus 2, and we have divided by 4p p minus 2. If you do a little bit of simplification, we get 4p, in the numerator we get 4p multiplied by p minus 2 multiplied by p plus 2, and then divided by 4p p minus 2. So 4p gets cancel out, p minus 2 cancels out. So the answer is the result is p plus 2. So on dividing, so the result is p plus 2, and hence the correct choice is C. C is the correct choice. Okay, let's do problem number 4. Problem number 4 says x minus 4 and x plus 7 are factors of which of the following expressions. So we are, in all the choices we are given some polynomials. They all seem to be quadratic trinomial, and we have to find which of these polynomials will have the factors x minus 4 and x plus 7. Okay, now it is not a good idea to factorize all the given polynomials and see whether which one is having a factors x minus 4 and x plus 7. So clearly you can see that the polynomial which will have x minus 4 and x plus 7 as a factors will be actually equal to x minus 4 multiplied by x plus 7. So the polynomial x minus 4 x plus 7, so this is we have to find that polynomial. We have to find the quadratic trinomial whose factorization is x minus 4 multiplied by x plus 7. So clearly we can see, you can consider that we know that x square, a polynomial of the form x square plus a plus b multiplied by x plus a into b is the factorization of this kind of polynomial where a and b are some constant is x plus a multiplied by x plus b. So if we are given these two factors, we can create the polynomial. We can create this polynomial. So we see that the factors are x minus 4 and x plus 7. So if we want to find which quadratic trinomial will have this factorization, we can straight away find that from the a and b, because we can consider minus 4 as a and 7 as b. Then I can say this will be equal to x square plus a plus b, that is minus 4 plus 7 into x plus a into b, that is minus 4 into 7. So this is equal to x square minus 4 plus 7 is plus 3x, and we have minus 28. So this must be the polynomial whose factors are x minus 4 and x plus 7, and hence the correct choice is choice A. A is the correct choice. A is the correct choice. Okay, let's do problem number 5. It says which of the following is not a factor of x to the power 4 minus 4. Okay, so we have to select the choice. We have to select the fact. We have to select the polynomial or the binomial which is not a factor of x to the power 4 minus 4. So let's quickly factor out. Quickly do the factorization of x to the power 4 minus 4, and then we can clearly see which of the choices is not a factor. So x to the power 4 is square of, clearly this is of the form a square minus b square, because x to the power 4 is square of x square and 4 is 2 square. So this becomes x square minus 2 multiplied by x square plus 2. Now x square minus 2 again can be factorized by using the identity a square minus b square, because x square 2 can be written as square of root 2, and now this thing is again of the form a square minus b square. So we can factorize it further as x plus root of 2 multiplied by x minus root of 2, and we have x square plus 2. So this is the final factorization of the polynomial x to the power 4 minus 4, and clearly now we have to see which of the choices is not a factor. So definitely choice A, x plus 2, it is not a factor. Choice B, x square plus 2, it is a factor. So B, C, D, we can clearly see are factors of the given polynomial x to the power 4 minus 4, and hence the correct choice is A, that is choice A, that is x plus 2 is not a factor of this polynomial. Okay, let's do question number 6. It says if 15 a to the power 6 minus 135 a to the power 4, an equation is given. The equation is 15 a to the power 6 minus 135 a to the power 4 is equal to k a to the power m multiplied by a minus n, a plus n, then find the value of k minus 1 divided by m plus n. So all the choices are some integers. So definitely we have to find the value of k and m and n. So to find the value of m and n and k, we have to factorize the polynomial given on the LHS, that is the left hand side. Now LHS, that is the left hand side, is 15 a to the power 6 minus 135 a to the power 4. So whenever you are doing some factorization of a polynomial, if you see all the terms are having some common factor, always take that common factor out. So I can clearly see that this polynomial is having two terms, and both the terms are having a to the power 4 as a common factor, and also we have to see the numerical coefficient. Now also 15 will be a common factor from the two terms. So because 15 divides 135 exactly, so the common factor of these two terms will be 15 a to the power 4, and we have a square minus 9, because 9 into 15 is 135. So we have this. Okay, now since on the right hand side of the equation we see the factors a minus n multiplied by a plus n, so clearly we have to factorize a square minus 9 further, and we know that it is of the form a square minus b square. So it becomes 15 a to the power 4. This is a square minus 3 square. So this will be 15 a to the power 4. A square minus 3 square is a minus 3 multiplied by a plus 3. So now we know that this is given to be as k multiplied by a to the power m multiplied by a minus n and a plus n. Now we have to compare both the LHS and RHS and find out what is k, m and n. Clearly we can see that k will be equal to 15. K will be equal to 15. A to the power 4 must be equal to a to the power m. So this implies m must be equal to 4, and also a minus 3 must be equal to a minus n, and a plus 3 must be equal to a plus n. So this implies n is equal to 3. So we have find out the values of k. We have found the values of k, m and n. Now we have been asked to find the value of k minus 1 divided by m plus n. This is equal to 15 minus 1 divided by 4 plus 3. This is equal to 14 divided by 7. This is equal to 2. Hence the correct choice is A. A is the correct choice. Okay, let's do problem number 7. It is saying that the sum of the factors of 4a square minus 13ab plus 10ab plus 10b square is. So it is asking what will be the sum of the factors of the given polynomial. So the polynomial is 4a square minus 13ab plus 10b square. Okay, so you can see that it is of the form a square plus it is exactly not of the form a square plus b square plus twice ab, but whenever you have this kind of polynomial where a trinomial where one term is in the form of a square and another term is in the form of b square and the third term is in the form of ab, then also you can apply the same concept of quadratic trinomial to do the factorization. That is, we will try to find two values, let's say m, two values, some constant values m and n, such that m plus n will be equal to minus 13, which is the coefficient of AB, and also we must have mn is equal to the product of the coefficient of a square and b square, that is 4 multiplied by 10 is equal to 40. Now if such values of m and n, if we can find some values of m and n such that m plus n is equal to minus 13 and m into n is equal to 40, then we can do the factorization of the given polynomial just by okay, let's see if we can find the values of m and n such that m plus n is minus 13 and mn is 40. Okay, so 40 the sum must be minus 13. So 40 we know can be written as 8 into 5, and we can see that 8 plus 5 is 13, but we have to have m plus n equals to minus 13. So we can say 8 into 5 is also equal to minus 8 multiplied by minus 5. Now we see the product is 40 as well as the sum is minus 13. So once we have found such two values m and n, we can say we will express this given polynomial as 4a square. Instead of 13, instead of minus 13, we will write m plus n. m plus n, that is minus 8 minus 5, and we have ab, and we have 10b square. So now if I do the product and open the bracket, I get this is equal to minus 8ab minus 5ab plus 10b square. Now I can see that I can form groups of the first two terms, and also this is group 1. If I form two groups where the first two terms makes the first group and the last two terms makes the second group, I can do the factorization, because I can see that from the first group I can take 4a as a common factor. So the first group becomes 4a, the product of 4a and a minus 2b, and also the second group is minus 5ab plus 10b square. So we form groups. So the concept of groups in factorization is that we collect few terms and form groups such that each groups will have a common factor. Now, okay, so we have this. Now this is equal to 4a and a minus twice b, and from the second group, that is this group, we can factor out 5b as a common factor from both the terms. So if we factor out 5b, we get minus a plus 2b, minus a plus 2b. Okay, so this is equal to 4a, product of 4a, a minus 2b. Now from this, from the expression minus a plus 2b, if I take negative as common, I can write it as negative of a minus 2b. So this becomes 4a multiplied by a minus 2b. I can bring this negative, that is the negative of a minus 2b. I can a negative of a minus 2b. I can bring that negative sign before the bracket, and this will become negative of 5b multiplied by a minus twice b. Now I see that both the groups are having a common factor of a minus 2b, and hence the final factorization of the polynomial will be a minus 2b multiplied by 4a minus 5b. Okay. Okay, so this is the factorization of the given polynomial, and the question has asked the sum of the factors. So this implies sum of factors will be equal to, so these are the two factors. These are the two factors, we have to find their sum, that is a minus twice b plus 4a minus 5b. So this is equal to a minus twice b plus 4a minus 5b, and now if you further simplify by adding the like terms, we get 5a minus 7b. So 5a and minus 7b is the sum of the factors of the given polynomial. Hence the correct choice is C. C is the correct choice. Okay, let's do problem number 8. Problem number 8 says the value of this divided by this. Okay, so it's a division of two polynomial. The dividend is ax square plus b plus ac x multiplied by bc plus bc divided by x plus c. So it is again a division of two polynomials, and we can see that the denominator is a binomial x plus c and the numerator is a quadratic trinomial. Because quadratic, because the degree of the polynomial is 2, because we are having x square. Now So we have to see if we can factor out, we can do factorization of the numerator, so that then it will be easy to perform the division, because possibly we can cancel out some factors from the numerator as well as from the denominator. So now the next task is to factorize this polynomial ax square plus b plus ac multiplied by x plus bc. Now if you observe carefully that, if you observe carefully, uh, uh, we are having the coefficient of x square is a, the coefficient of x is b plus ac, and we are having the constant term bc. Now this, if you, this is of the form, this is of the form p x square plus qx plus r. This is of the form quadratic trinomial px square plus qx plus r. Now we know that we can factorize this polynomial, that is a quadratic trinomial px square plus qx plus r, if we can find two numbers m and n such that m plus n is equal to q and m into n is equal to pr, is equal to pr. If we can find such numbers m and n such that m plus n is equal to q and mn into n equals to pr, okay, then we can factorize. Now you can clearly see that in this polynomial we are having the coefficient of x is already a sum of two constant, that is b and ac. Also you can see their product, the product of b and ac is abc, which is also the product of bc and a. So we see, we observe from the given polynomial, in the given polynomial we observe that we observe that okay. Well, I think you can, instead of you can clearly break this down. Okay, sorry. Let's not bring the reference of the quadratic trinomial to do the factorization. I think it will be more easy and simpler if we just straight away uh, simplify if we straight away simplify the product, further simplify the given polynomial, that is if we do the product of the b plus c into x, and we get bx plus acx plus pc. Now we will try to form two groups or groups such that each group will have a common factor. This forming of groups by choosing suitable terms so that each group will have a common factor, this you have to do by observation. You have to carefully observe the terms and see which terms you can consider for each groups, so that all the groups will have a common factor. Now if I consider these two groups, I can see these two groups, that is the first two terms forms the first group and the last two terms forms the second group. I can see that from the first group, this is group 1 and this is group 2. From the first group I have x as a common factor, and the other factor will be ax plus b. So this is now, so we have formed the two groups, group 1 and group 2, where group 1 is ax square plus bx and group 2 is acx plus bc. Now if you we see that the group 1 is having a common factor of x. So if we factor out x, we get x multiplied by ax plus b, and from the second group we see that we are having a common factor of c. So if we factor out c, we get c multiplied by ax plus b. Now we clearly see that both the groups are having a common factor of ax plus b. So the final factorization will be x plus c multiplied by ax plus b. So Now we can say that this will be equal to x plus c multiplied by ax plus b divided by x plus c. So x plus c cancels out and we are having the result as ax plus b, and hence the correct choice is C. C is the correct choice. Okay, let's do problem number 9. When one polynomial is given, when the polynomial is expressed as a square of ax plus b, then the value of a plus b is. Okay, so the given polynomial is, it is saying that this polynomial, that is 2 multiplied by x square plus 6x minus x minus 6 multiplied by x plus 6. It is saying that if this polynomial can be expressed as the square of ax plus b, that is ax plus b square, then what will be the value of a and b? That is, it is asking the value of a plus b. So we are having this kind of equation where we have to find the value of a and b. So basically the problem is, so basically what we have to see is that we have to factorize the left hand side polynomial and see if we can factor that this polynomial in the form of a square of some binomial, uh, and then we will match that square with the ax plus b whole square. So let's try to factorize this polynomial. Okay, so we have 2 multiplied by x square plus 6x, and we have x minus 6 multiplied by x plus 6. Now you might be initially tempted to find the product of x minus 6 multiplied by x plus 6, which will be x square minus 36, and simplify the whole expression as a quadratic trinomial. You can do that, and of course you will you will get the correct solution. But if you observe carefully, if you consider this as a group 1 and this as a group 2, from the group 1 I can factor out x as a common factor, and I will get 2x multiplied by x plus 6, and I have x minus 6 and x plus 6. So now you can see that we are having the common factor of x plus 6 from both the group. So this can be factorized as x plus 6 multiplied by 2x minus x minus 6. So this becomes x plus 6 multiplied by 2x minus 6 plus minus x plus 6. This is equal to x plus 6 multiplied by x plus 6, which is equal to x plus 6 whole square. So this is given, and it is given in the problem that if the given polynomial is expressed as a square of ax plus b square, so this is given to be as the square of ax plus b. Now we can clearly say that if square of x plus 6 is equal to square of ax plus b, it clearly means that x plus 6 is equal to ax plus b, and this clearly says we can equate the coefficient of x and the constant terms, and we get a is equal to 1 and b is equal to 6. So this implies a plus b is equal to a plus b is equal to 1 plus 6, which is equal to 7, and hence the correct choice is C. C is the correct choice. Okay, let's do problem number 10. It is saying that if x minus y, xy minus 3, comma xy plus 3, comma x square y square plus 9 are the factors of the expression, x to the power p, y to the power q minus m, then the value of square root of m divided by p plus q. Now, okay, so three binomials are given. Three factors are given of a given polynomial. So basically, it is saying that this polynomial x to the power p, y to the power q minus m, this polynomial when factorized uh, should give xy minus 3 multiplied by xy plus 3 multiplied by x square y square plus 9. Why? Because these three are given factors of this polynomial. So that means that the product of these, the product of the given factors must be equal to the polynomial. Now let's see what is this. Let's find out what is the product of this product of the factors, because we can clearly see it will not be a tedious task, because xy minus 3 multiplied by xy plus 3 is of the form a plus b multiplied by a minus b. If you perform the product of these two factors, clearly we can see this is of the form a minus b multiplied by a plus b, which is equal to, we know that, a square minus b square. So this will be xy square minus 3 square, and we have the last factor, that is x square y square plus 9. So this becomes square of xy can be written as x square y square, and minus 3 square is minus 3 square is 9. Okay, so we have now again the form a plus b multiplied by a minus b. So this is of the form a minus b, and this is of the form a plus b. So we can say that this will be equal to a square minus b square, that is square of x square y square minus 9 square. So this becomes x to the power 4 y to the power 4 minus 81. So the product of the given three factors is coming to be x to the power 4 into y to the power 4 minus 81. This must be equal to x to the power p y to the power q minus m. So clearly, if you compare both the LHS and the RHS, we can clearly say that p will be equal to the coefficient of x, the power of x will be same if we compare the two expressions of the both on the LHS and the RHS, we can clearly say that the power of x must be same, the power of y must be same, and the m must be equal to 81. So that is, p must be equal to 4, q must be equal to 4, and m is equal to 81. So this implies now we have been asked to find the value of square root of m divided by p plus q. This is equal to square root of 81 divided by 4 plus 4. Square root of 81 is 9 and 4 plus 4 is 8. So 9 by 8 is the value of the given expression, and hence the correct choice is D. The correct choice is D. Okay. So this brings to an end in solving the set 2 of 10 good problems on the chapter of factorization. I hope this video was beneficial, and these problems are good enough to judge your understanding of the chapter concepts, and these kind of problems, 10 good problems, I will keep on making these kind of problems, 10 good problems from each chapter as and when they are completed in the other playlist, that is CBSE Maths 8 RS Agarwal. And So this was set number 2. I hope you have also watched the previous video where I solved another 10 good problems from the set 1 in the set 1. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.